Good morning. It's Saturday morning and I'm getting WebAssign done. I have an audience of one. He's attentive. Let's go. All right, so DDS, matrices. They've actually given you this matrix. I'm going straight to number 2, by the way. I didn't do number 1. It's one of the FC questions I've done a few times. If you do have questions on it, just email me, diana.thomas@westpoint.edu. Even if you're not in my section, it's fine. So A is this coefficient matrix here, and D is the minus 14.4 or minus 7.2. So pull those out. I always like the DDS to be pulled out too. I think it's much easier to look at this in Excel. So in Excel, I would put in this recursion equation. The 1.2, 0.2, and 0.6, and 0.8 come from the coefficient matrix. The D vector is this minus 4.4 and minus 7.2, and the A0 and B0 are given like this. Why is this important? Because you can graph this. So let's see. I have the initial conditions put here. I put the values in and I plotted them. So this is the problem that you have. And I can now see that these things are converging to infinity. I even know what the sign of the largest eigenvalue is. The absolute value of the sign of the largest eigenvalue must be bigger than 1. So I can see certain things and I can match up my solutions. So why do we do some of the stuff we're doing today? Well, 20 years ago when this class was designed, there was no way to actually do this without the analytical solution, because we had a program called MathCAD, which was not very good, and Excel wasn't on everyone's machines. But now from your fingertips, you can see what's happening, and kind of it's made the other part obsolete. Anyways, let's move on. The first question is to determine the analytic solution and describe the long-term behavior. Step 1 is to find P star. And I've put my code in here, but I'm going to walk you through the Mathematica code. The program, so I have everything on my Teams in a folder. So you go to Files, Mathematica Crib Sheets, and then you can go over to the one that says how to find the equilibrium vector. So click that, download, it's downloaded. There it is. Pull it up. So it has instructions in here. Don't mess with that. Just go straight to the matrix. If you're clever, you can just go change the matrix the way you want it to. So I'm actually going to screenshot in this problem so I don't have to keep copying and pasting it. So I'm going to pull that in. And that's a trick you can do too. It comes from a common complaint of cadets that they have just one screen. So do I. So it's irritating. I'm just going to go here and just modify what was in here before in the template. And if you want any of these, I'm happy to share them with you. Just email me at diana.thomas@westpoint.edu. So that's my matrix, and I'm going to go display as matrix so I can see it. I know you have the nice templates and everything. I'm still doing old school. Then I put in the D vector, which was the minus 14.4 and minus 7.2. Pop it in there. In it goes, and then display as matrix. And then I need to find the identity matrix minus A. I don't have to do any work. I already punched in A, so I just go Shift Enter, and I'm going to display that as a matrix. And then I'm going to row reduce I minus A with D. There's already a matrix in here. So the slickest way that we can do this is by going to this matrix form here, copying this, Control C, going down here, highlighting those 4 components, not the part of the augmented piece, and then doing a Control V. And it's not going to be exact, but I don't care. It's doing its Mathematica thing. On the right side, you see the D vector. Highlight the D vector here, Control C, and put it here. Control V. And then go to the side and hit Shift Enter. I get asked all the time,